Hey guys, Mike here. So today I'm going to talk about my projects for information retrieval at Johns Hopkins University. It's going to be about an attempt at detecting policy alignment to manifestos. So the problem is, how do we determine if a policy document supports or advances a political manifesto's goal? How do we determine if a policy document, for example, an executive order would be a policy document? How do we determine if an executive order supports Project 2025, the manifesto Project 2025 goals? Um, so that is important because a lot of lawyers or domain experts want to know possibly if a policy supports another policy, or if a policy supports a political manifesto like Project 2025. Making sure if the executive order or bill or Supreme Court decision aligns with those goals. An example would be an executive order promoting merit hires. A specific executive order 11246 might align with Project 2025 of removing DEI. Human lawyers, so the lawyers, the actual people from that look into this, argue that EO 11246 supports Project 2025, and so we need to ask ourselves: can we automate this using techniques from LP and IR? Um, so can we make a algorithm or model to figure out if a policy from an executive order supports a political manifesto or supports another policy or something like that. So here are some related works. Um, TF-IDF, we should all know this. This is what kind of started everything. However, it doesn't really work in our case because TF-IDF only um, figures the term frequency and doesn't really care about semantics. BERT is kind of the next step. BERT figures out the semantics instead of just term frequency. It figures out the meaning of a sentence or word using vector embeddings. The next step is cross-encoders, which is kind of similar to BERT, really. And then DeBerta using NLI. NLI is natural language inference. And natural language inference is actually really important, and it's actually what is needed to figure out if a policy supports another policy. The dataset construction. So this is a dataset. I have dataset from the Project 2025, which contains the ground truth and all the policy proposals from Project 2025. It's organized by department and it's reviewed by humans. It's like, yeah, so it's actual ground truth of if an executive order supports another proposal. And then I have the executive orders data set from 2021 to, sorry, 2001 to 2025. And I'm looking to 5 presidents and 1,000 something executive orders. Okay. And then the train test split is pretty small. I have 292 for training and 78 for testing. This means for the machine learning models. TF-IDF IR model. So this is the first model that I tried out, and it just does not work. It doesn't really learn anything. It doesn't really carry over semantics. So it's just a complete failure. So let's go to the next model. The next model is BERT. BERT makes more sense because it now actually captures the semantics. However, the problem with just semantics to see if two documents are similar. So if two documents have similar semantics, have similar meaning, that kind of tells you if they support each other, but not really. Um, and I'll go into a reason why. There's also a bug where with my BERT model that I don't know how to solve really. There's some overfitting happening, and I think it's because I think the overfitting is happening because um, the data set is too small, or the ground truth is too small for the train test split, and also the semantics isn't what we really need. It's not. We're just not looking for just semantics. We're looking for something else. The cross-encoder is very similar to BERT. Does a slightly better job, but when I look at the results, but what we really need is natural language inference. Um, and what natural language inference does is that it gives us entailment and gives us it solves the question if a document or text logically follows another document or text. And it doesn't really give us a similarity score. So no similarity score given from natural language inference. Instead, it tells us if one document logically leads to another document and doesn't contradict it. Instead, if it supports another document through logic, um, which is what we really need to know if a policy logically supports or contradicts um, the goals of a manifesto. So NLI can also detect indirect support, which is actually really, really helpful. And indirect support, an example of indirect support is a proposal to reduce emissions, a executive order that says carbon reporting requirements. Carbon reporting is required now. They aren't semantically similar. So a document about reducing emissions is not semantically similar to carbon reporting requirements. However, a lawyer or a human would see that um, one supports the other, so they really should be aligned. And so NLI can also detect one entails the other logically, so can a human. And so they should they support each other basically. And so that's why we need NLI, natural language inference, to figure that out. Well, semantics like BERT doesn't really do that. So here's the complete pipeline. Um, so first we collect the data from various websites. Then we create the ground truth from that data set. The ground truth is very small. And then we train the model from the ground truth and test it. There's a bunch of different models I tested. The only one that really is helpful is NLI. And then I did some evaluation analysis and some stats, or checking some stats. And here are the results of the different models. So the alignment percent is, okay, so the models are the models. So alignment percent is how many EOs aligned with the uh, Project 2025 manifesto, and university EOs is an indication of overfitting. University EOs are basically EOs that somehow aligned with every single proposal, which is an indication of overfitting. So we want EOs, university EOs, to be low. Runtime is how long it took to train and test the model, or just running the model. So you'll see that the NLI, which is the one that we want, which is actually useful, only takes 1.5 hours, which is not too bad compared to other models. And then why did BERT fail? One is that I think I overtrained it, and another thing is that so I overfitted it, and also what do I call it? Uh, I overfitted it, and also the semantics, we're not really looking at semantics actually. We're looking at inference or entailment. So that's a novel contribution that I kind of just want to share. In IR, we talk a lot about similarity scores, but we never really talk about entailment or what one document tells another document. Which is important for to see if one document logically supports another document or logically contradicts another document or indirectly supports another document or directly supports another document. So here are some examples. So the proposal to reduce greenhouse gas emission and the executive order to require annual carbon reporting. This is just an example. But the NLI, the natural language inference model, can figure out if reporting logically follows from reduction or other way around. Will reporting carbon stuff mean a reduction in carbon stuff? And yes, this logically follows. And so, if a manifesto said something about reducing greenhouse gas and someone made a executive order, then yeah, it entails. So conclusion, we want NLI for policy stuff and yeah. And the future work is just look at other manifestos and policy documents. And questions and answers, you can email me. And there are some documents or visualizations, but I can't really share them because I'm kind of out of time. So if you want them, just email me.